So let's start with the first aspect of two-dimensional motion, that is the displacement. So very first thing that we need to know is our XY plane. A 2D grid with intersecting horizontal and vertical axis for locating points. That's our XY plane that we have seen over here. So this is our XY plane. The grid system that we're looking at is our XY plane. So we have the X and Y over here. Next, position vector. The next definition that we need to know is position vector. Guys, by default, wherever you see I and J, they are with I cap and J cap. I can either bolden it like this or write caps. But yeah, I've not done over here. So please ignore that. That is a lot of work. So I have not done that, right? So please see to that you understand, or you put on in your notebook caps. Now, position vector. What is position vector? It describes the point's location in XY plane using vector notation. We use rectangular components. You should be able to understand what are rectangular components. So this I and J and all of this are your rectangular components. This has been taught in vector chapter. To express the position vector, that is xi cap plus yj cap, where x is your horizontal component and y is your vertical component, right? So that again we have seen few examples before. Actually, okay, let me just take a. I'm not able to do it. I'll do it here. So I'm taking some random point. Scale is 1, guys. Everywhere the scale is 1. I'm cutting down a lot of writing so that we don't waste time. This is y and x. That's 0. So we have 1, 2, 3 count, right? This is 3 and 1, 2, 3, 4, 5. 5. It's -3, indicating it's to the left. So a position vector is nothing but a line that starts from origin and connects to that point. All of this is taught again in your vector chapter. Position vector of point P is given by -3 I cap plus 5 j cap. Okay. Now, one more example is 2 I cap plus 3 j cap. Let me do that. 2 I cap, this is 2, and 3 is over here. So that would be your next position vector. -2 I cap and 3 j cap, if I'm right. And we have -4 j cap, -4 I cap and -5 j cap. -4, I'm not able to write it over here, so I'm showing it here. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. It would be so. Okay, that's your answer for the second example over here. Which is the position vector of which is a position vector in fourth quadrant? So which is it? Fourth quadrant. Answer is D. Can you imagine why is it in fourth quadrant? So let me take it over here. So we have 1, 2, 3, 4. 1, 2, 3. So this is it. 4 I cap and -3 j cap is in fourth quadrant. So that's that. Next. Yeah. So the main heading was displacement vector. So we have to understand XY plane. And we need to understand position vector before we talk about displacement vector. That's why we read those two. Now, the change in position from one point to another in a XY plane is your displacement vector. Is your object has got displaced. We use rectangular component to express the displacement. So change along the x I cap plus change along the y j cap, where delta x is change in x cap, delta y is change in y cap. Right? Let's have a look. So let me okay, so there's a bit of division. It's okay, doesn't matter. Say a point moved from, I'll pick a random point. It moved to this point. So the position vector of this point is, or let me do something else so that it's kind of looks nicer. Yeah, that point might look better. So this is the position vector of where the particle started off with, and this is the position vector of where the particle is ending with. So we are moving from point, say C to D. Now the displacement vector is a line connecting C to D, a straight line connecting that, right? CD is your displacement vector. Now, what is the position vector of point P? So let's write that part by part. So position vector of C, not P, sorry. C is, so we have 1, 2, 3, 4. 4 I cap and 2 J cap. While that of D is 1, 2 and 1, 2, 3, 4. 2 I cap minus 2 I cap and plus 1, 2, 3, 4. 4 J cap. Right? So now if you have to figure out the displacement vector, all you have to do is quite simple. Let me actually remove the graph paper. Yeah, that's better. So displacement CD will be given by the change along the y-axis, sorry, x-axis I cap plus the change along the y-axis j cap. What is the change along the y-axis? This is from and this is to, remember. And that's your x component and that's your y component. Right? So I moved to minus 2 from minus 4. From 4 actually, so minus 4. So you need to subtract that value. Plus I moved from or to 4 from 2. And your answer would be minus 6 I cap plus 2 j cap. And that will be, that's your answer. Right? So one more example is if a particle moved from 2, 3 to minus 1, 5. So we have minus 1. So the position vectors are position vector of point A and B. Of point A is 2 I cap plus 3 j cap. And point B is minus I cap plus 5 j cap. Then what do we have? Then my displacement vector would be change along the x and change along the y. So this is my to place, this is from place. From this to this, yes. So it will be basically minus 1 minus of 2 I cap plus 5 minus 3 j cap. So can you see what is happening over here? So we are dividing the x and y into two different parts and handling it separately. So we are handling it one thing at a time, and we are combining with a plus sign. So again, we are going back to the same funda. We are going back to this very idea. Key idea to understand two dimension is to realize every complex path can be simplified. That is breaking down into single movement along two different directions. Right? We're just doing that. We are continuously doing that, nothing else. Okay, so that is your displacement vector. So displacement is always a movement from a point to another point, and it can be anywhere on the graph. It need not be just from the origin. Position vector always start with some origin, some reference point, and using position vectors, we'll be able to discuss the displacement vector. Okay, so it's quite simple, right? Not that hard. That's it. If you think that this is simple, you're pretty much done, honestly. Okay, now you guys have to copy.